This is video 2 for lesson 3 in unit 8 of chemistry 2. So in the last video we talked about what is pH, and we said it was a measure of our hydronium ion concentration. Now we're going to use this equation. pH is equal to the negative log of the concentration of H3O+. And remember that H3O+ is the same thing as H+. And we have to make sure that we use molarity. So we're going to use a new button on the calculator, and that button is right here on our class calculators. I'm not sure where it is going to be on your calculator, but you should try to find a log button. I know that there's one on the iPad calculator also. So this button is what we're going to be using, and all we do is put in our molarity, which is given in our problem. And this is how we put it in the calculator. So we hit the negative sign and hit log. And you can see that brings up parentheses. Now I'm going to put in my 1.25 times 10 to the negative fifth. Remember that when we put in scientific notation into the calculator, we use the EE button, which is a second function right here. So I'm going to put in 1.25 second EE, negative 5, close parentheses, and then hit equals. Now, I'm going to round this to 3 significant figures because my molarity is in 3 significant figures. So my pH is equal to 4.90. No units on pH. So here is our answer, no units. So if we look at the next page, we can talk about the inverse of pH. So if we're given a pH, how do we find the H3O+ concentration? Well, H3O+ concentration is equal to 10 to the negative pH. So, if we look on our calculator, I'm going to clear this off. You can see that right above log we have a second function. It says 10 to the x. That is the inverse log function. So, we have to write 10 to the negative pH. The pH is going to be the exponent, and we take the inverse of it. So, our H3O+ concentration is equal to 10. Well, if we're given a pH of 2.75, we take 10 to the negative 2.75 power. So I'm going to hit second log, and then I'm going to put in negative 2.75, close parentheses, and hit equals. Now, this number is not in scientific notation. It's very typical that we put them in there. On these calculators, we're going to use this combination of buttons on the top where it says sci-eng. So I'm going to hit second, that button. I'm going to use the arrow to go to scientific, hit equals, and it puts my calculations in scientific notation. 3 significant figures, so we get 1.78 times 10 to the minus third. And don't forget to put molar on there, so this does have a unit. We also can calculate something called pOH, and pOH is a measure of basicity. And it's calculated the same way, except we can use the OH minus concentration. So pOH is equal to the negative log of our OH minus concentration, and OH minus is equal to 10 to the negative pOH. So if you remember, we talked about water having a pH of 7. Well, water is fairly unique because it self-ionizes, which means that if we put water in a container, and we just have a container of pure water, it is going to ionize, and we end up getting OH minus and H3O plus. But it is very, very small quantities that break apart. Because of the electronegativity of oxygen, it can rip an H from here. So one of these acts as an acid, one acts as a base. We get a conjugate base and a conjugate acid according to the Bronsted-Lowry theory. Well, if we were to measure the H3O plus concentration for this reaction, we would end up with 1.00 times 10 to the negative 7th, which would give us a pH of 7. But since this is a 1-to-1 ratio, we would also end up with an OH minus concentration equal to 1.007 times 10 to the minus 7 and give us a pOH of 7. So that means that we have a pH or pOH of 7. So water is considered a neutral substance. And because of this fact, we end up with something called the dissociation of water constant, which is called Kw, and it is equal to OH minus times H3O plus, which is equal to 1.00 times 10 to the negative 14th. This is going to be a relationship between the OH minus and H3O plus and anything that is going to be a solution in water. So if we know one, we can find the other. So that gives us some additional equations that we can derive from all of these other ones. So pH plus pOH is going to equal 14. So now we have this calculation, we have this calculation, we have these two, we have this one up here on top, and from our previous page we have this one. So we have 6 different equations that we can use when going over problems.